Hey sharp pixels, welcome back. Since my previous paradoxes video was successful, I decided to make another one. This time it's on Schrodinger's cat, so it's really complicated. Well, there goes 90% of my audience. This video idea was commented on my previous video on paradoxes. If you want me to make a video on something, then comment down below. This video made me lose a lot of brain cells. One view is equal to one brain cell back to me. No, but seriously, if this video gets 180 views, I'll have enough brain cells back to make a video on many worlds theory, which is related to this one. So please like the video. Schrodinger's cat is an experiment that was designed to point out flaws in the Copenhagen's interpretation of superposition. I wasn't joking earlier when I said it was very complicated. Anyways, but unfortunately, as we'll see later, he wasn't correct, he being Erwin Schrödinger. The theoretical experiment is conducted with a cat in a steel box with a radioactive substance which has a 50% chance of decaying in 1 hour. There will also be a Geiger counter, a tool that is used to measure radioactivity, and a hammer and a poisonous liquid in a glass beaker. Seriously, doesn't look good for the cat, does it? As I said earlier, the radioactive material has a 50% chance of decaying in 1 hour. So there is a 50% chance that the Geiger counter will detect whether the radioactive material has decayed, and if the material has decayed, then it will trigger the hammer and break the poisonous glass beaker, spilling the liquid and killing the cat. Now we see why the experiment is theoretical. But remember, this only has a 50% chance of happening. The Copenhagen interpretation was first posed by physicist Niels Bohr in 1920. It says that a quantum particle doesn't exist in one state or another, but in all of its possible states at once. It's only when we observe its state that a quantum particle is essentially forced to choose one probability, and that's the state we observe. Since it may be forced into a different observable state each time, this explains why quantum particle behaves erratically. Schrödinger designed this experiment to state how ridiculous the theory was. Because the box was closed and no one could see the cat would be in a state of superposition and it would be both dead and alive at the same time. Now common sense says that makes no sense. But in the quantum realm, nothing really makes any sense because you see, at the subatomic level, that includes protons, electrons, and neutrons, these particles make up an atom, and an atom is something that makes everything around us. These subatomic particles behave in a wave-like manner, just like light, but are also in a particle form. So when these objects are not disturbed, the waves overlap each other. Thus, the particle can be in a state of superposition, but when we observe it using an electron microscope, we are disturbing them. How? When we observe subatomic particles, we use a beam of electrons. These beams scatter these subatomic particles, so they get disturbed and appear to be in one state. Well, that's it for this video, and don't forget to like, share, subscribe and comment down below. See you in my next video. Bye.